Vector is a multi-mission ISR platform used for aerial reconnaissance. It is completely electric with an endurance of 3 hours, primarily used for intelligence, surveillance, and reconnaissance missions, as well as target acquisitions, fires missions. It is assembled in 2 minutes by one operator without any tools and launchable in 5 minutes. It is a 2-in-1 aircraft that has a fixed wing and a multi-copter variant. The Vector AI platform uses artificial intelligence with the OKSI OMNINAV software, allowing the Vector to automatically update its position in real time constantly.
On board this platform, we can run all sorts of autonomous applications, such as GPS-denied navigation, visual-based navigation, with AI feature matching algorithms. We can run geolocation applications for pulling high precision grid coordinates in the absence of GPS, as well as conditional behavior logic. So flying a true autonomous mission without, not just waypoint to waypoint, but actually making decisions on the fly and adapting the missions on the fly based on what is seen and is not seen with things like ATR and other computer vision models.
OMNISCIENCE is a suite of containerized AI applications for generic drone use. So we've partnered with Quantum Systems for their Vector AI nose cone, which adds these suite of applications to the Quantum Systems Vector VTOL aircraft. The point of OMNISCIENCE is to enable drones to have next generation capabilities such as GPS-denied navigation, object detection and tracking, terminal guidance, and conditional behaviors for true autonomy in denied environments. What this allows us to do is basically penetrate any denied airspace and provide very high quality position information to the aircraft comparable to GPS. That'll allow the Vector aircraft to go many kilometers into a denied airspace, and the vehicle will know its position very reliably while it's flying around. That enables you to locate targets of interest and then hit certain points of interest for your mission. OmniSeek is a onboard real-time object detection capability for drone systems. So this allows the drone to recognize targets of interest, such as people, cars, military targets as well, onboard the processor on the aircraft. This allows it to recognize things of interest and when there might not be a pilot present to fly the aircraft. So in a fully denied environment, there might not be a day link. You still want your aircraft to go into that space and identify targets of interest and then make decisions based on what it's observing. So what separates OmniNav from other industry offerings is that it combines two separate approaches that both have pros and cons, but when combined together provides a truly robust generic GPS-denied navigation capability. So what most other offerings have is that they offer global localization, but those models are typically very cheap and not very capable. Our system uses the latest neural network technology from industry, and we train it on a very large satellite data corpus that allows the model to have the best generalization across many different types of satellite imagery and camera imagery you might encounter. For example, your imagery might be old. It might be taken at a certain time of year. So if you're flying your aircraft in winter and the imagery was taken in summer, traditional methods typically fail during those times, whereas OmniNav's models can handle those changes. A lot of times in warfare as well, your environment gets destroyed. You'll have destroyed city blocks with craters, lots of destruction, and OmniNav can handle those changes because of the expressibility and power of its models. So in addition to OmniNav, we also are shipping OmniLocate. OmniLocate uses the same AI-based matching technology for satellite imagery, but it does it for the ISR camera itself. So during ISR, traditionally, you have your aircraft's position, you have the camera's pointing direction, and then you have your elevation data that gets intersected with that pointing vector from the camera. The problem is all of these have errors associated with them. So the aircraft has some error with its position, the gimbal has pointing error, and then your elevation map has error. So when you say point to a certain target on the surface of the Earth, that's going to be off by sometimes even a full screen width. So instead of looking at McDonald's on a corner, you're looking at Starbucks across the street. OmniLocate, you can pre-cache maps on board the vehicle, and then what we do is we take that camera footprint and we solve for that error, and then we can adjust the camera footprint so that anything that we do observe is plotted very precisely, typically on the order of Cat 1 coordinates or less than 5 meters of error. What this allows the aircraft to do is go out, perform a mission, plot targets of interest, and we know that the coordinates that it can broadcast on the tactical mesh data link have very high quality so that you can pass them to another precision weapon system.
The current iteration of Vector has flown thousands of hours in Ukraine and other operational areas. We have taken the lessons learned from those operations to develop enhancements and improvements to the next iteration of the Vector, which we call Vector AI. Namely, the platform is more modular, allowing you to use multiple different technologies from our company proprietary. So the Vector AI actually has 2 NVIDIA Jetson Orin boards. One is in the payload used for the OKSI software, and the other NVIDIA Jetson Orin board is on the fuselage, and it's used for the autopilot system. So there's multiple different AI functionality with the aircraft. So the Vector AI utilizes a downward-facing boson FLIR infrared camera, which updates the position of the aircraft automatically in flight at all points in time. So the pilot no longer has to update the position of the aircraft manually. The OKSI software will do that.
Quantum is one of those manufacturers, UAS manufacturers, that really thought ahead, and rather than designing an aircraft with compute that can do just what the aircraft needs to fly, they really put an excessive amount of compute power on here for future expansion and future capability enhancements. If you pay attention to the news these days, EW environments are very harsh, right? There's a lot of equipment that needs to be protected, and so big expensive jammers are out there blanket jamming everything. So RF communications is very unreliable, and you can lose platforms pretty fast by entering an EW environment. And then GPS is jammed, so your platforms can quickly get lost or go to the wrong area or be looking at the wrong target without GPS. A lot of platforms out there and a lot of operators and pilots that can't fly, right? They go outside of their tent or the base. They try and sense to see if the environment's being jammed, and if it is, they wait until it's not jammed and then they fly then. By providing autonomy capabilities and GPS-denied navigation and autonomy, you can kind of fly anytime, any place, and that's what customers and operators are so excited about, is to know that their platform can be used anywhere, anytime, without restrictions because of adversarial jamming techniques and other methods.